Hi everyone, in this video we are looking at section 4.5, example 1b. We will be solving radical equations involving square roots as well as variables inside the radical. In this equation, we have a slightly different situation from the previous one. So here we don't just have a radical equal to a number, but we have a radical plus another constant equaling a constant. So we have an extra step. Our goal, of course, is to isolate the variable x. Before we can isolate x, we have to actually isolate the radical. And in order to do that, we have to get rid of this plus 3. Remember, we are using inverse operations in order to achieve this isolating x. So in this case, because we have plus 3, we have addition, we now need to use the inverse of addition, which of course is subtraction. So we are going to subtract 3 in order to cancel this plus 3. But whatever we do to one side of the equation, we must do to the other side. So we're actually going to subtract 3 from both sides. So let's go ahead and do that. Now on the left, we just have the square root of x minus 1. And then plus 3 and minus 3 would just give us 0. We're not going to write plus 0. We just write this equals then the right side, which is 4 minus 3, which is 1. Now we're one step closer. Now we want to isolate the x. We want to get at what's inside the radical. So we need to get rid of the radical. In order to do that, we perform the inverse of taking the square root, which is squaring. So we will square both sides. We just put a set of brackets around that so that we're clear that the square applies to the entire radical, and then that equals 1 squared. In our next step, we can simply get rid of the radical now, because the square root of x minus 1 times the square root of x minus 1 would just give us x minus 1. And of course this equals 1 squared, which is 1. We really just have one more step now to fully isolate the x and solve for x. Here we have x minus 1. We just want to know what x equals, not what x minus 1 equals. So we must perform the inverse of this subtraction, which of course is addition. So we are going to add 1 to both sides of the equation. And then that leaves us with, well, x minus 1 plus 1 would just leave us with x. And of course, 1 plus 1 is 2. So we have found that x equals 2. And now the next step in our process is to verify this solution to see if it's correct. So we start by writing the original equation, x minus 1 plus 3 equals 4. Now, in place of the x, we write the 2, the answer to our previous problem. So we're going to just plug that in for x. So we have the square root of 2 minus 1 plus 3 equals 4. And now we just continue with the process. And of course, we don't actually know that this is equal. So I should be clear and write a question mark here because we are really verifying, right? And it's not until we get down to the very last step and we see that the left side does indeed equal the right side that we have verified. So right now we're just kind of testing it. So 2 minus 1, of course, is 1 plus 3. And we're wondering if that equals 4. The square root of 1 is just 1, so we have 1 plus 3, possibly equaling 4. And of course, we know now at a glance that 1 plus 3 indeed is 4. And we have verified that the left side equals the right side. And because of this, we can conclude that x equals 2 is a solution. And now, once you've written that, you're finished.